What is going on, guys? And in this video I would like to teach you how our famous two-dimensional array is actually being stored in memory. On one hand, it seems that it's stored as a matrix or a table with rows and columns, but we will see that it is actually a little bit different than what it looks like. And the understanding of this topic is so important both for you as a future programmer with good skills as well as a preparation for your future interviews questions. You see, a lot of interviews regarding C programming language include some tricky questions about two-dimensional arrays, and this topic of the physical representation in memory is one of them. So make sure you're prepared. You'll thank me for that later. Alright, so now let's us begin. Okay, so to do that, okay, to understand the memory representation, let us quickly recall our usage of one-dimensional arrays. So if, for example, we declared an array such as int arr and 5 elements, then in this case what happened is that we've created 5 elements in a sequence stored one after the other in the memory of our computer. And we know that we can access each of the array's elements by using indexing. For example, arr at index 0, and this will give us the access to the first element of the array, arr at index 1, and the access will access the second element, and so on. And also another thing that we can do is to print their addresses. So if, for example, we are going to print the address of the first two elements by using printf element 1 address equals to %lu and the address of the first element and the address of the second element, and we use here the %lu just to print the address in some decimal representation so that it will be just simply easier for you to understand the concept that I'm about to teach you. And of course, for those of you who are already familiar with the usage of %lu, there are of course few nuances that I don't talk about here because that's not the point of this explanation. So simply refer to it as just the printing of the address of an element in just some sort of decimal representation. So anyway, let's say that the address of the first element was 3000, then in this case the address of the second element would be 3004 and 3008 and so on. And basically that's the case since it's an array of integers and every integer consumes 4 bytes of memory. So if you would like to, if you would print the addresses of the other elements in this array, you will come to see that they are kind of organized one after the other in the memory, which is exactly what we know, right? But now what will happen if we will create a two-dimensional array with 2 rows and 3 columns and try to print the addresses of each of these elements? But before we do so, just one thing that I want to ask you. Please stop the video right now, go 10-15 seconds to where we spoke about one-dimensional arrays and the addresses, and just run this part of code on your computer. So run this code on your IDE and make sure that you understand the results that are being printed and you understand everything that you see, okay? So let's get back here to our two-dimensional array. So here we just created a two-dimensional array and we print the addresses of the elements of each of the elements of this array. So we print the addresses on the first row and then the addresses on the second row and so on. And surprisingly, what we can see here is that all the elements of the two-dimensional arrays array are simply stored one after the other. Okay, so that's what happens behind the scenes in the actual memory of your computer. You can see that the address of elements at row 0 and column 0 is just 16 at the end, then 20, 24, and then at the new row, it's kind of, it continues, right? So if we come to break it even further, we can see that this two-dimensional representation, the representation that is easier for us to imagine, is actually stored like this as a sequence in the memory of your computer. And if we wanted to take a real look at how this two-dimensional matrix or two-dimensional array looks like in memory, it would be something like this. Okay, so that's basically the representation in the memory of the computer behind the scenes. Okay, so two-dimensional array, as we are, like, you know, treating it and thinking about it as a grid of columns and rows, actually behind the scenes it's stored just like that. So let's just point it out here. So you can see here that everything seems to be sequential, 4 bytes, one after the other. So meaning we think about a two-dimensional array like this, but actually behind the scenes it is stored as a sequence of elements, one after the other, and that's the first row and that's the second row. And you access the first row by using mat at index 0, and if you want to access each of these columns, so you access it like mat at index 0, 0, 0, 1, 0, 2, and here, okay, here guys, I just want you to understand that it's not going to be 3, 4, 5, okay, I just left it from the previous example, but it will be again 0, 1, 2, so here is not 3, 4, 5, 0, 1, 2, because we are accessing mat at index 1, which is row 1, row at index 1, which is the second row, and we are going to access each of the columns, so 0 should be here, 1 should be here, and 2 should be here, okay? So basically, this is it. Very important video on how the memory represented behind the scenes for the matrix and for the two-dimensional array. Very important to understand. For some reason, I've encountered that interviewers really like to ask questions which are pretty much to check your understanding if you really understand the core and what happens behind the scenes, and not only to initialize and use a two-dimensional matrix. So thank you guys for watching, and I wish you good luck if you are going to an interview or you are going for some exams. And yeah, this is it. Goodbye.